Welcome back friends. Derivative of inverse trigonometric function. We shall find the derivative of sin inverse x. Friends, watch the complete video for a proper knowledge. If you are new here, please subscribe the channel and press the bell icon for the future updates. Friends, let sin inverse x is equal to y. The domain of sin inverse x is minus 1 less than or equal to x less than or equal to 1. And when only principal value are considered, we have minus pi by 2 less than or equal to y less than or equal to pi by 2. Sin inverse x is equal to y can be written x is equal to sine of y. Okay. So friends, differentiating both sides with respect to x, we get ddx of x is equal to ddx of sine of y, isn't it? So we can write here 1 is equal to ddy of sine of y into dy dx. Okay. So 1 is equal to cos of y dy dx. Friends, here we can write dy dx is equal to 1 upon cos of y. Okay. Now friends, denominator cannot be equal to 0. So obviously cos y is not is equal to 0. Number it 1, and since cos y is not is equal to 0, we can write y is not is equal to plus minus pi upon 2. That is, x is not is equal to plus minus 1. Okay. Now pi upon 2 minus pi upon 2 less than y less than pi upon 2. So it implies that cos of y is greater than 0, isn't it? So we can write from here cos y is equal to root over 1 minus sine square y. That means root over 1 minus sine square. Sine y is equal to, what is sine y? Sine y is equal to x. So we replace it 1 minus x square. Cos y is equal to 1 root over 1 minus x square. So friend, from where started? From 1 we can write dy dx is equal to 1 upon cos y. What is cos y? Cos y is equal to root over 1 minus x square. So dy dx is equal to 1 upon root over 1 minus x square, where minus 1 less than x less than 1. Okay, this is the condition. So our trigonometric function was sin inverse x, which is considered as y. So y is equal to sin inverse x, and now finally we are getting here dy dx is equal to 1 upon root over 1 minus x square, where minus 1 less than x less than 1. Thank you. Have a nice day.